So there you go, there's the answers there and the calculations on the slides. Cool, excellent. So this is what I want you to do next. And again, I've given you these in your sheets, so page 103 and 104, okay? So basically question 96. I have given you 4 data sets there. Now what I want you to do is 3 things. First of all, before you do any calculations, I want you to decide on a single value that you think best represents each data set. So literally the task which I got you to do right at the very beginning, okay? So before you do any calculations, just look at it and go, I think this value best represents it. Then I want you to go ahead and calculate each measure of central tendency. So in other words, the mean, the median, and the mode for each data set. And then I want you to think. I want you to decide which measure of central tendency, which average best represents each data set. Or perhaps which one doesn't represent the data set best. Does that make sense? You'll see what I mean if you get going. So first of all, decide on a value for each data set, then calculate mean, median, mode, then think, this measure isn't very good because, or this measure is good because. Okay, so we have the 4 data sets there, right? First of all, for data set 1, right? Let's look at data set 1. What number did you decide best represents the data, best represented it? So before you did any calculations, what number did you think best represented this data set? 7, okay. Then you did the calculations. So what did you get for the mode?
7.
What did you get for the median?
8.
What did you get for the mean? 7. York, where have you been? Where have you been? I mean, just doing that doesn't answer my question.
I don't know. I'm sick.
You're sick? Okay, but now you're better? Good. Okay. Right. Okay, so what did we get for the mode, sorry? For the first data set? 7. What did we get for the mean?
8.
What did we get for the median?
Median 8. Mean 7.
Okay. So the median we got as 8, sorry? I think everything should have been 7. Let's just go back and quickly calculate it. Just make sure that you're putting the data set in order first. Vatican. Did you put the data set in order first? Right, that's where you went wrong then. Okay, so you always put the data set in order if you're going to deal with median. So everything should be 7, okay? So in this case, does any measure of central tendency stand out as being either good or bad? Not particularly in this case. I think any of these would have been fine. Any of these would have been fine, okay? Have a look at the next one. So what number did you decide on for the second data set before you did any calculation? 4? Yeah, I think 4 is a reasonably good guess, okay? Okay, so then what did you get for the mode? 4. What did you get for the median? 7. What did you get for the mean? 7. Now have a think. Clearly, if the median and the mean both come out as 7 and the mode comes out as 4, there's something going on here. What's going on here? So what measure of central tendency do you think is better or worse? What's your opinion? Okay, so carry on thinking about that one. Let's have a look at the next one. What number did you decide before you started looking at it? 2? Yeah? You got 1? Ahmed, did you get something else?
No, I'm lost. I don't know where we are.
Okay, so this third data set here.
The third one?
Yeah, what did you get for the mean?
I didn't calculate the mean yet.
Okay, so somebody else. Did somebody calculate the mean?
Neutral.
Sorry? For the third one?
So.
What did you get for the median? Okay, what did you get for the median, somebody else? 2. What did you get for the mode? 1 and 2, okay. So in this case, the mean comes out as something wildly different. Can anybody think why?
The mean, what's the mean for the third one?
Was it 7?
Yeah. 7.
The mean comes out as 7, whereas the mode and the median came out as something much lower. Can anybody think why the mean comes out as something different? Because remember, these numbers should all be the same, or roughly the same.
On the numbers.
Right, so have a look at that third data set. Why did that mean come out as so much higher than the median or the mode?
Because the largest number is 55.
Exactly. So in other words, it gets attracted, the mean gets attracted towards that outlier. okay? Because you're adding all these numbers together eventually, okay? Whereas the mode and the median, they don't consider all the numbers, they just kind of consider somewhere in the middle. Does that make sense? Okay. What about the last one? What number did we decide on? 7, 6, something like that, yeah? What do we get for the mean? 7. What do we get for the median? 3. What do we get for the mode? 7. Okay, so in this case, the median came out as something different. Why?
Because it's different numbers.
Exactly, it's different numbers. It all depends on the spread of the data set, doesn't it? So the median depends, so the mean depends on the spread of the data set. The median depends on the spread of the data set as well in a way, okay? And the mode, well, it depends how many numbers, how frequent the numbers come up, okay? Because it might be that one number comes up more frequently than the others, but actually if a number comes up twice and another number comes up once, that doesn't necessarily mean it's automatically a good measure of central tendency. Does that make sense? Really, with the mode, what you should be looking for is if a mode comes out significantly more than all the other numbers. Okay, so more frequently than all the other numbers. For example, if a number came up 10 times and all the other numbers only came up once, would you be happy that then a mode would be a clear choice? Yeah? Whereas actually, if a number only came up twice and all the other numbers came up once, that probably wouldn't be a good measure of central tendency. Does that make sense? Okay. So to illustrate my point further, let's see. Okay. I want you to think about this. In fact, no, before you do that, okay, on GeoGebra, so GeoGebra, I've got a GeoGebra channel, which is Maths Partner, okay. If you wanted to play around with this, just type in central tendency with drag and drop data points. Go to GeoGebra, which is a website, okay. In fact, if you wanted the website address, it's there at the top, so geogebra.org/m/Kilo Golf Romeo Foxtrot Delta Delta Juliet uniform, okay. So you can type that web address in, and then you can play around with this activity. Now the idea is, what I've done here is on the right hand side, I'm going to create a form of histogram, basically a bar chart, and the left hand side in this circle here, I have data points. And the idea is that you can literally drag and drop these data points over here, and you can see where the mean, the median, and the mode are going to lie depending on the distribution of your data, okay? So you can, by all means, have a play around with this. So for example, if I put a data point at 2 and another data point over here at 10, are you happy that the median and the mean is in the middle? Because it's a measure of central tendency, it's got to be in the middle, okay? But then suddenly, if I start to pile more on the 10 one, are you happy that the median and the mode are kind of still based around 10? Does that make sense? Yeah? Whereas look what's happening with the mean. So for example, if I start dragging the mean all the way down there, can you see that what happens is, with the mean always gets attracted towards that outlier. Does that make sense? Now, if you think back to what we were doing with, where is it? Is it going to go? Okay, if you think back to what we were doing with the third one, we said the reason why the mean comes out so wildly different is because we had that outlier there. We have that data point that lies outside the rest of the data, the 55. Does that make sense? Yeah? So by all means, have a play around with those, okay, and to get a feel for it. But in the meantime, and again, I'm going to give you 3 or 4 minutes to have a look at this, could you think about what each average would be in each case? So in other words, what the mean, the median, and the mode would be for each question. And then hopefully that will give you more of an idea of when things start to break down or not. So shall we talk through them? I think that might be easier, right? So, okay, what is the average number of legs? Now, I've just said average, so it could be mean, median, or mode, okay? What's the average number of legs? So what's the modal number of legs? 2. Most people have 2 legs, right? What would the median number of legs be?
1 plus 1. 1. Is it?
Not quite. It depends, okay? The way which I want you to visualize median is imagine you've got everybody in the population, so everybody in the world, all 7.7 billion people in the world, and they all stood in a line, okay? And you stood in a line in order of the number of legs which you had. So the people with no legs would be right at the beginning of the line, okay? Then you'd go through all of those, you'd end up with the people then with 1 leg, okay? Then you'd have the people with 2 legs. Now what I want you to do is to walk along that line and then stop when you get to the middle position. So that person in the middle position, the person you stop by, how many legs will they have? 2. Yeah? Because few people have 0 legs, few people have 1 leg, the majority of people have 2 legs. The majority of the line, maybe 90% of that line, will consist of people that have 2 legs. Does that make sense? Yeah? What would the mean number of legs be, though?
2. No, wait.
Yeah, it's going to be less than 2, right? Why has it got to be less than 2?
Because not all people have 2 legs.
Exactly right, yeah? So in fact, we can illustrate this on the board, okay? So for example, let's suppose we had one person with 0 legs, so we took a data set at random, sample at random. One person had 0 legs, one person had 1 leg. And then everybody else in the data set had 2 legs. So let's see, 1, 2, 3, 4, 5. There's 6 people, which I've chosen at random, okay? One person has 0 legs, one person has 1 leg, and then the remaining 4 people have 2 legs, okay? Now, if I add all this together and divide by the number which I have, which is 6, can anybody quickly calculate that? What is that equal to? Yeah, exactly, yeah? This is equal to like 1.5. Now, in reality, this isn't a fair sample because in reality, the majority of people in the data set would be having 2 legs. But you're happy it's got to be a number less than 2. Why has it got to be a number less than 2? What do we know about the mean? What's it attracted to?
To the outlier.
To the outliers. In this case, the outliers are the people with 0 and 1 legs. Yeah? So in other words, that mean is going to get attracted towards the 0 position.
The outlier here is 0 and 1?
Yeah, because less people have, or few people in life have 0 or 1 leg. The majority of people have 2 legs.
So the outlier is like the distant lowest number?
The outlier is a number which lies outside the majority of the data set.
Oh, okay.
Yeah, so 0 and 1 legs is outside the majority. So remember, it should be 2. We know it should be 2. The median tells it should be 2. The mode tells us it should be 2 legs. But because the mean is always attracted towards that outlier, it's going to get pushed towards the 0 and 1. So it's in reality, if you looked at the mean, it'd be like 1.8, 1.9 number of legs. Is that okay? Does that make sense to everyone? Yeah? Hence why you need to be careful when you say the word average, because it could mean 3 things. Okay? Okay, what's the average number of testicles?
1.8, 1.9?
Have a think. Notice I haven't specified here whether we just include males or females. Let's assume we're including both.
Oh.
What's the average number of testicles? So what would the modal number of testicles be if we include both females and males?
2.
Would it be 2? 2 and 0.
Oh, yeah, yeah.
Because you're thinking about mode, right? Females will have no testicles. Males will have 2 testicles, mostly. Okay? So in actual fact, in this case, this is an example of what I was talking about. This is bimodal data. In other words, there's 2 modes that fit this data set. Okay? So either 0 or 2. What if I was talking about median? So in a median, we put all the females at the start, all the people with 0 testicles, and then we have the people with 1 testicles, and then we have the people with 2 testicles, and the people with 3 testicles, etc., 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 right? And we walked along that line, and we stopped when we got to the halfway position. How many testicles do we expect that person to have in the halfway position?
1? Maybe?
Probably, because we're assuming that we've got the same number of males and females. In fact, it's not strictly true. There's more females than males.
Really?
Yeah, it's about 60-40, I think, in terms of population of the world. But, yeah, you need to be careful. It's a bit more of an ambiguous question, okay? It's probably not going to be 2. It might be 1, or it might be 0, yeah? So median there is a little bit harder to think about. But what about mean? What's the mean number of testicles?
I think it'd be around the median.
Yeah, so what do you reckon? Give me a number.
1.
Yeah, I'd say about 1. Yeah, because if you add them all together, you're going to have some people in that data set with 1 testicle as well, right? There's going to be 2 plus 2 plus 2 plus 2 plus 2. And then you're going to add in a few 1s. So it's going to be somewhere between 1 and 2. Yeah, it's going to be somewhere between 1 and 2. Good. Okay. What's the average number of sexual partners? So what would the modal number of sexual partners be, do you think? Just give me a number.
1.
Yeah, 1, 2. It'll be a fairly low number for most people, right? What would the median number of sexual partners be? So in other words, you put people in order according to the number of sexual partners they've had. You walk along that line, you get to the halfway position. How many sexual partners do you expect that person to have?
All of their lives? Probably several.
Yeah, exactly. So I would say probably about 5 or 6. Yeah? Most people have about 5 sexual partners in their life, right? But what would the mean number of sexual partners be?
2.5.
I think it's going to be more than that because there's some people in life who have slept with like 500, 600 people. You remember that like the mean is always attracted towards that outlier. So because there's like 1 or 2 people in life that are like very, very busy, they get pushed, the mean gets pushed towards those people.
There's a king once that had 500 children.
There you go. So he's had sex at least 500 times. Well, 500 people. Hang on, wait, what? No, that's the number of sexual partners. That's not the number of times he's had sex.
I'm not sure, but I'm pretty sure he had like.
Is it with
500
different
children or
women?
something. Huh?
If it was with different women, then yeah.
Yeah, he was a different one.
Okay, so each child was with a different woman. Okay, fair. Wasn't that, Mongolian?
Yes, something about Mongolians.
Who's the guy from Mongolia? Pot, wasn't it? No.
The biggest
Genghis
number-
Khan.
The biggest. Oh yeah, that's the guy.
Yeah, he
Biggest
was a
number
very
of
nasty guy.
Children a woman can have, not have, like the record is 64 children.
64 children.
She had triplets and quadruplets at the time.
I'm not going to say anything. Okay, yeah.
She's Russian.
Was she?
Yeah.
Okay. Fair enough, okay. Let's move on quickly. What's the average income?
I guess about £1,000.
Yeah, so if you want to talk about modal income, it's probably going to be between 20 and 30,000 pounds. If you want to talk about median income, again, probably about the same, probably about 30,000, I'd say. But if you want to talk about mean income, that's going to be significantly higher because you've got millionaires in the world and billionaires in the world. So that mean is always going to be attracted towards that outlier. Does that make sense to everyone?
Yeah.
Okay, fine.